Imagine a world where movement is impossible, where every step, every lift, and even the simple act of breathing become a challenge. This is the power of the muscular system, a complex network of over 600 muscles that work behind the scenes to keep us moving. How do muscles contract so precisely? What causes them to develop, strengthen, or weaken with time? And how can you increase muscle function to boost performance and longevity? In this in-depth look at the muscular system, we'll watch about the intriguing mechanics of movement, the science of muscle growth, and the essential measures for keeping your muscles strong, flexible, and resilient for life. 1. The structure and types of muscle. The human body has around 600 muscles, which are divided into 3 categories: skeletal, smooth, and cardiac. Skeletal muscles are related to bones and allow for voluntary movement, such as walking, lifting, and jumping. Smooth muscles found in the digestive tract, blood arteries, and other organs work involuntarily to support vital biological functions. Cardiac muscle, which is specific to the heart, contracts rhythmically to circulate blood throughout the body. These muscle groups work together to assist movement, keep posture, and regulate internal functions. Muscle fibers are organized into bundles that contain myofibrils made up of actin and myosin proteins. These proteins cause contraction using the sliding filament theory, in which actin and myosin glide past each other, shortening muscle fibers and generating force. The interaction of different muscle groups ensures that the body moves smoothly, circulates efficiently, and organs operate properly. 2. How muscles contract to generate movement. Muscle contraction happens at the microscopic level via a process known as the sliding filament mechanism, which is triggered by the interaction of actin and myosin filaments. When the brain transmits messages to motor neurons, the neurotransmitter acetylcholine causes an electrical impulse in muscle fibers. This impulse causes calcium ions to be released, allowing the myosin heads to attach to actin and pull the filaments together, resulting in muscular contraction. This process gets its energy from ATP adenosine triphosphate, which is essential for muscular contractions and relaxation. Muscle contractions are divided into 2 types: isotonic and isometric. Isotonic contractions cause muscles to change length, such as when lifting a weight. Isometric contractions occur when muscles generate stress without changing length, for as when maintaining a plank. The exact modulation of muscle contractions enables smooth, regulated movements for all physical activity, from simple daily tasks to rigorous sporting performance. 3. The nervous system's role in muscle movement. The nervous system is essential for muscular movement because it delivers and coordinates impulses that control both voluntary and involuntary motions. The central nervous system, CNS, which consists of the brain and spinal cord, processes information and controls muscle activity. The peripheral nervous system, PNS, transmits these signals via motor neurons that connect with muscles via neuromuscular junctions. Reflex actions, like as removing a hand from a hot surface, occur via spinal reflex arcs and do not require conscious awareness. Proprioceptors are specialized sensory receptors found in muscles, tendons, and joints that provide feedback on body position and movement, helping to maintain coordination and balance. The neurological system also plays an important part in muscle memory, which allows repeated motions to become habitual over time. Proper neural function is required for fine motor abilities, coordination, and posture maintenance, demonstrating the close relationship between the neurological and muscular systems in facilitating movement. 4. Muscle development, strength, and endurance. Muscle development, or hypertrophy, happens when muscle fibers are stressed and repair themselves, becoming thicker and stronger. Resistance exercise stimulates this process by inducing tiny injury to muscle fibers, which activates healing systems and increases muscle size and strength. Strength training increases both muscular strength, the greatest power a muscle can generate, and muscular endurance, the ability to endure repeated contractions over time. Proper nutrition, particularly a sufficient protein intake, promotes muscle repair and growth. Furthermore, constant training, progressive overload, gradually increasing resistance, and rest are critical for growing muscular strength and endurance. The significance of flexibility in muscle health. Muscle flexibility is a muscle's capacity to stretch and move across its whole range of motion. Maintaining flexibility helps to prevent injuries, improves posture, and increases overall movement efficiency. Stretching techniques such as static stretching, holding a stretch, and dynamic stretching controlled movement. Based stretching aid with muscular suppleness. Regular flexibility exercise lowers the likelihood of muscle stiffness, strains, and imbalances, which can contribute to injury. Muscle health is also dependent on regular hydration, balanced nutrition, and adequate rest. Furthermore, disorders such as muscle atrophy, loss of muscle mass due to inactivity, emphasize the significance of ongoing physical activity for long-term muscle health and overall well-being. 6. Common muscle disorders and their impact. Several conditions impair muscular function, resulting in weakness, discomfort, and limited movement. Muscular dystrophy, MD, is a class of hereditary illnesses marked by increasing muscular weakness and degradation. Myasthenia gravis is an autoimmune illness that disrupts neuromuscular communication, resulting in muscle tiredness and weakness. Fibromyalgia produces widespread muscle pain, stiffness, and exhaustion, which is frequently connected to faulty pain processing in the neurological system. Cramps and spasms are caused by sudden involuntary muscle contractions, which are frequently brought on by dehydration, electrolyte imbalances, or overuse. Tendinitis and muscular strains are frequent overuse injuries that produce inflammation and pain. Treatment for muscular diseases varies, but it frequently includes physical therapy, medication, and lifestyle changes to alleviate symptoms. Understanding these disorders stress the necessity of muscle care, early detection, and preventive actions, such as correct warm-ups, hydration, and recovery tactics in preserving muscle health and function throughout life. Conclusion: the muscular system is the foundation of movement, allowing for everything from simple motions to major athletic accomplishments. Maintaining muscular mass becomes increasingly important as we age, preventing weakness and loss of independence. Strength training, stretching, and being active are not only for athletes, they are beneficial to everyone. The more we care for our muscles, the better our body will function. So whether you want to gain strength, avoid injuries, or simply stay active as you get older, maintaining muscle health should be a lifelong goal. Understanding and nurturing your muscular system helps you build a stronger, healthier future one movement at a time. Let us know in the comments what you think about the muscular system, how muscles move the body, and don't forget to like, subscribe, and stay tuned for more captivating content on our YouTube channel.